Welcome you, myself MP Misra, Faculty School of Computer and Information Sciences, IGNOU. In this video session, I am you with a topic related to working of the computer system, or what actually the content which makes a computer system work and work properly, work efficiently, and how actually a computer system is coordinated and managed. As in the previous video we discussed about the basic components of the computer system, we touched upon in that particular discussion about the CPU, that is the central processing unit. So in this video we will be discussing little more about the central processing unit and how actually this central processing unit works. So as we know, the computer is an electronic device and it is used for the purpose of some kind of processing, some kind of storage, and obviously if we are having some specific problem and we have written the code, so we are expecting for some desired output, and that output is received to us. And how actually these things are happening? These all things as a human being we also do. If we need some data, we take from some outside agency. If we need to work on that particular data, our brain work on that particular data, it process it on the basis of certain assumptions, on the basis of certain requirement of treatment on that particular data, and obviously once that particular data is processed, some result comes, and on the basis of that we take several decisions in our daily life. It means there is some agency or some component in whole system which should be responsible for taking care of several aspects associated with taking data and then processing and then producing the result. And what about if some intermediate results are coming, then whether those intermediate results also should be stored somewhere, or they should be used for some kind of further decision making in whole system. So for these all things, in a normal human being, our brain work for that. But in computer science or in computer system, if we talk about what actually a brain-like thing is, so we can give an analogy of brain of human body to a CPU. So CPU can be seen as a brain-like component in the computer system, and that perform all the activity. Now if we are saying that CPU is brain of computer system, then now you can visualize or you may think about that what are the different activities of the CPU. It means almost all the controlling activity, almost all the processing activities are now responsibility of the CPU, because as our brain do, it take care of all the body component, it controls all the activities of all the body components, and it also takes some input from the external agencies, and it process on the basis of a specific context or the question around which that particular input is taken, and then process it. And in human body we are having some preconceived knowledge, we are having our experience, we are having a set of knowledge available with the faculty of our brain, and on the basis of retrieval of those individual knowledge we perform the things and we make the decision. It is not that all the knowledge all the time is coming in our brain and it is being processed. It is as per the specific requirement of that particular specific knowledge or instruction which come in our brain, and we try to process that. Similarly, in computer system also, you might think computer system like it is having a repository of so many things, so many softwares are stored in that particular or installed in that particular machine, but at a time if you are working on a specific software, that software should be loaded somewhere to the memory, and that particular memory is the main memory, and for that we will be discussing little detail in the coming sessions or in coming videos in next week. So CPU is also like that. Whenever the requirement of execution of a specific program is there, that particular specific program is loaded in the main memory. From there the CPU take those specific instructions or control operations, and on the basis of that it performs those things. Now if further we talked about that where CPU reside or how we can identify that what is the CPU. So if we try to look inside a computer system, so our computer system, inside that particular machine we are having a chip, and that particular chip is generally of the size of postal stamp or little longer, and that particular chip is having very large number of circuits, very large number of integrated circuits available in that, and there are multiple layers also in that particular circuit, and those layers are performing different kind of activities. So it is a very complex and very compact circuit design, and that particular circuit design is performing almost all the operations of the computer system. So this is one of the most important component or most important part or ingredient put it on the motherboard of a computer system. So CPU is also known as processor. As we normal conversation or common language say that if you are having a machine, what is the processor of that particular machine? And even for the smartphone also, for some time we talked about that what is that particular specific processor. So CPU is also termed as processor, and the job of the processor is to perform different kind of processing activity, and the quality of the machine or quality of the computer system or the capacity of the computer system depend on the capacity of the processor, and capacity generally we observe that what is the actually speed of the processing of that particular processor, and that speed is measured in terms of the megahertz, and it is represented in terms of 1 megahertz means 1 million instruction cycle per cycle, or per second 1 million instructions are being performed. So if a machine is having capacity to execute, let us say 300 megahertz, or it is of that capacity, it means that particular processor is having capability to process 3 million cycle per second. It means it may be some instructions need more than one cycle. So in that way, around 3 million instructions you are processing, or some less instructions if one instruction is having more than one cycle involved in that to perform the operation. So you can think about if you are having a very large capacity processor, so that processor provide you lot of capacity or lot of support to process the complex application or larger application. If you are talking about some, let us say a large distributed system like banking system is being managed, so the server or the machine which are having those CPUs, those different CPUs are performing on very large scale or on very large speed, then only they are matching with the specific requirement of that particular system. Similarly, for the scientific application, or you take some military application and other some real-time application like navigation system, or if you are talking about management of the traffic system. So these all critical systems are having very fast capacity CPU, and even the term supercomputer come, it means supercomputers are having very large number of CPU, and all those CPUs are having large capacity, and their processing speed is much higher. And if we talk about the very basic working of the CPU, so we can say that CPU read the instructions, then execute those instructions, perform calculations, perform some kind of decision making or logical operations. So main CPU can be seen as, or the main responsibility of the CPU can be seen as to read the instruction, and on the basis of that either perform some calculation, whether it is arithmetic calculation or logical calculation, or some kind of control activity. That control activity may be that reading data from the secondary storage device, storing data to the secondary storage device, similarly managing input output devices. So these all things can be taken care by the CPU. It also handles the information from one part of the computer to another part. It means communicating information from one section to another section, or from one component to another component is also managed by the CPU. If we try to visualize CPU in terms of a simple block diagram, so we can say that CPU is having two major components, or with a simple formula we can represent a CPU equal to CU plus ALU. CU is the control unit of the CPU which is responsible for controlling the different activities, and ALU is the component of the CPU which is responsible for performing all the arithmetical and logical operations. And obviously one attached component is also there, that is not part of the CPU, that is the primary memory or main memory, and all the instructions and data is basically transferred from the secondary memory to primary memory, and from that primary memory CPU try to read that particular, and if there is some speed mismatch, some other kind of faster memories are also used, like some special registers or some cache memory, and that help to match the data availability and the speed of the communication of the CPU. So now you can think CPU as a very capable and very fast processing component of the computer system. It is working on the instruction and data. But if our data is not provided with that particular specific speed to the CPU, so there will be a mismatch. That's why majority of the time it is reported or it found that the computer system is not fully utilized, because different devices which are being used in the computer system, especially the storage devices, they are not matching the speed of the processing unit or the processor. That's why there is a lag between the availability of the data and the processing capability. Processing is always having higher capability and capacity, but data is not available, so obviously the utilization of CPU cannot be reached towards the 100%. It is very, very difficult to reach 100% utilization of the CPU. And broadly, if we list the main function of the CPU, so we can list that particular in a way that it reads the input as per the direction of the control unit, as control unit is responsible for managing the different devices like input device, output device, storage device. And once it is read, so that particular instruction either will be some kind of controlling or performing different kind of decision making instructions, or it may be some kind of arithmetic instructions. So if it is arithmetical operation instruction, then control unit transfer that particular arithmetical operation activity to the ALU, and ALU perform that particular arithmetical operation. If some kind of decision making operation is there, then obviously that particular also will be transferred to the ALU, because control unit don't perform any type of calculation. Its responsibility is to control the activities. And finally the processing is completed by the help of the control unit and by performing the operations or instruction by the ALU, then that particular result is transferred to the main memory. But if that particular main memory again will be transferring information to the secondary memory for the purpose of storage, to the screen, or that is our monitor, for the purpose of visualization. So IO devices management also will be happening in parallel. So any operation you can see will be having involvement of the control unit as well as ALU to reach to the desired output. So again I repeat, the main important component or main part of the CPU are control unit and arithmetic unit, and control unit can be seen as a component which controls the entire operation of the computer system, and it read the instruction or it take the instructions or fetch the instruction from main memory, and then that particular instruction as per the type of instruction are executed either by the control unit or it is transferred to the ALU to perform the operation, and processing is done on the basis of that particular set of instructions. Also, the control unit can be seen as a nervous system of whole operation of a computer system. As we said that if our CPU is brain, so the control unit is a nervous system which is, now you can think that is controlling all the activities of the system, and our ALU is the processing system which is processing what kind of activities? Mainly two kind of activity. One is the arithmetical operational activities, another is the logical operational activities. If we talk about arithmetical operation activities, so we can say that all the arithmetical operation, whether it is multiplication, division, addition, subtraction, and these all operation on different type of data. Different type of data means the data may be a whole number, that is the integer, or it may be a floating point number. So floating point operation or normal integer operation, those all arithmetical operations are performed by the ALU, and control unit manage and decide that what kind of operation will be managed by the CU, managed by the control unit, or what kind of operation will be transferred to the ALU to perform the operations. Now, If we look further about the working of the control unit, so control unit is basically performing two operations. One is it is fetching the data or instruction. Fetch means it is reading the data and instruction from the main memory, and it is keeping those things to the specific registers which are specifically designed for different activities, and then it is decoding those instructions. And once those instructions are decoded, on the basis of that the control unit decide that which particular section will be performing the operation or control of activity should be given to which section, whether the input device should be given control to provide some kind of input, or the control should be given to the output device to display some information on the screen, or if some kind of processing activity like arithmetical or logical operations are there, that should be given to the ALU. And the control unit manages all these activities on the basis of a specific counter that is known as program counter. Basically, program counter is a kind of pointing mechanism which manages that if one specific operation is being performed, let us say at moment, then what instruction will be performed in the next moment, that is managed with the help of program counter. So basically, program counter is helping to find out the next instruction which to be executed in the queue. So it is managing the sequence of instruction to be performed with the help of the control unit operation. So this is one of the most important component of the control unit, that is the program instruction. And as I mentioned that this fetch and decode, this fetch and decode operation is known as fetch and execute also in combination. Fetch means reading the data from the memory, and execute means then decoding that specific data. If I am saying data here, data means whatsoever has been loaded in the memory, that is some data, and that data may be of two types. One may be it is instruction, second may be it is data for the purpose of operation. So those things are loaded in the main memory, and from there those things are decoded, and on the basis of the specific code written and instruction written, it is perform the operation on the basis of that. So control unit is having mechanism to manage the IO devices. It is having mechanism to manage the sending the result to the specific output devices, or getting some intermediate result, and then how that particular intermediate result will be managed. And instruction register is used for performing different kind of operations, that is decided on the basis of that how actually the activities will be performed, which is given in terms of certain instruction in the program or in the application. So instruction register contain the current instruction which is going to be executed from the primary memory, or basically instruction register read the next instruction to be executed from the primary memory, and then it decide that what kind of instruction to be executed on the basis of the specific circuit or the availability of the specific instruction provided. And as I mentioned that program counter contain the next instruction which is going to be executed in the sequence, and specialized electronic circuit is used for the purpose of controlling the specific unit design for the purpose of fetching the instruction and then decoding those particular instruction and then performing the operation and managing the intermediate results. And when that particular intermediate result is converting into final result, then that particular final result should be either displayed to the output device or it should be sent to the storage unit, that is also managed by the control unit. And as I discussed, ALU, the job of the ALU is to perform the calculations or operations, and those particular operations belong to two categories. One is the arithmetic operation, another is the relational operation, and that relational operation may be some kind of comparison, whether equal to, greater than, less than, and these all operations are pre-decided on the basis of the program code written for the specific application solution. And by execution of those individual instructions in a given sequence or in a given conditional situation, the result is arrived. It means it's totally depend on how actually the instructions are written, and on the basis of that only those instructions are decoded and executed and final result is reached. Now, if we take a very simple example of adding two numbers, let us say, if we are having two numbers and we have to add that particular two number, obviously those two numbers should be read first, then that particular should be stored in a result, and once that particular result is there, that result should be transferred to some output unit, or it should be transferred to some secondary storage device to permanently store that particular result. So, in that context, it can be seen that in first step, what operation CPU will perform? CPU will move the total instruction. That total instruction is what? Read two numbers, then add the result of those two numbers, and then store that particular result in somewhere in third number or third variable, and then finally either display that particular result to some output device or store that particular result in permanent storage. So, in that way, in the first step, the whole instruction will be read, and that whole instruction is the reading of two number, reading of the instruction for adding those two numbers. So, these all things will be loaded in the main memory. From main memory, then control unit will load those things in the specific registers, and on the basis of that it will decode those instructions available, and on the basis of that it will perform the operation, and finally result will be displayed. So, in that way we can say that the control unit is one of the key component of performing all the operations, because it is responsible for fetching the instructions from main memory, whether it is data or whether it is some kind of program code. So, those all things are read, and in which register those things should be kept, that is also decided by the control unit, whether it is some kind of arithmetical operation or it is some kind of control operation, that is also decided by the control unit, and accordingly the work is distributed or dispersed to this different component of the computer system to perform the operation. So, here with this I conclude this session. In next video you will be learning more about the storage devices and related concepts, and wish you a happy learning.